Uh, Okay, hi, I'm Ryoma Shinto, and I'll be presenting analyzing the sensibility of visual language models using evolving image generation system, focusing on color impressions and sound symbolism. Yeah. Here's our outline for today's presentation. Yeah, introduction. The central question is, can visual language models acquire human-like sensibilities through learning? And to what extent can VLMs, which have different learning process from humans and lack a physical body to explore, so exhibit sensibilities similar to humans through learning from text and image data? So our study focuses on two sensory aspects, color impression and sound symbolism. And color impression is the mental images evoked by colors, and sound symbolism is the sound of words evoke specific images. Yeah. For instance, a previous studies have shown that the color red evoke a sense of combativeness, and the classic example of sound symbolism is Bouba-Kiki effect. When we asked which shape is Kiki and which is Bouba, most people associate the sharp shape with Kiki and the round shape with Bouba. Yeah, so in analyzing sensory aspects of VLMs, we face several challenges. And the vast number of parameters makes interpretation extremely difficult. And the sheer volume of training data makes comprehensive analysis impractical. High performance models are often closed and obscuring their learning process. So here, changing our perspective, we propose the evolutionary approach to analyze the sensory aspects of VLMs. Yeah, evolution is a continuous process of adaptation to environment, and where individuals with suited to their environment are more likely to survive. So by analyzing the process of evolution, insights can be gained about the environment. Yes, so our method involves setting up specific environments related to sensory aspects of VLM and analyzing the emerging trends to gain deeper insights. Okay, so let me explain our methodology. Yes. Yeah, our research is based on an algorithm called Conrad that can generate images with various colors and geometric patterns using genetic algorithms. Here's how Conrad's image generation algorithm works. There exists a genome consisting of 30 characters from A, T, C, and G. And each of the 64 possible codons, which are three-letter combination of these characters, is associated with a specific mathematical function. Yeah, there we start with a random initialized matrix, and we then apply the function corresponding to each codon in the genome to this matrix, and apply, and last, after applying all the codon is a genome, we generate an image from the resulting matrix, image generation. Yes, and this diagram illustrates the overall process of Conrad. First, 32 images randomly generated in the initial generation are evaluated by humans on an 11-point scale rating from 0 to 5. And this image is a combination of 32 individual images merged into a single image arranged in 4 rows and 8 columns. Okay. Then fitness values are determined based on this evaluation. And parents are selected using a roulette wheel strategy, followed by crossover and mutation. Yeah. Then this constitutes one generation. And as this process is repeated, The images evolve in accordance with the evaluator's sensibilities. Next, here's an overview of our system. And we've developed a system that incorporates both human and VLM evaluations using Conrad. Yes, first, either the VLM or human is presented with a prompt, and two images. And let me explain this process first. Okay. Yes. Okay. The VLM or human evaluator is presented with two images along with a prompt. For example, the prompt might ask which of the two presented images give a more calm impression. We can insert color word, is this one, red part, corresponds into the color word. Then the evaluator provides an answer based on this prompt. This process is repeated to conduct a tournament among all images in the same generation, determining their rankings. We opted for a tournament format because providing a 11-point scale evaluation is challenging for VLM. Yeah. And after ranking all images in a tournament format, this one, fitness scores based on these rankings, fitness score. Yes, the subsequent steps are same as in Conrad, parent selection, crossover, mutation. Yeah, so we used Google Gemini Pro as our model, and we set the population size to 32, generation is 30, and mutation rate is 0.1. Okay, experiment. First, there is 3 experiments, and first experiment 1 focused on color impression, investigating how words the evoked color impression in human affect the VLM's color impression. Specifically, we use the word warm, aggressive, and cold and calm. Previous studies have shown that these words evoke specific color association in humans. That is words like warm and red, aggressive red, cold, calm, blue and green. So we investigated whether VLMs would exhibit similar tendencies. Yeah, each experiment was repeated 5 times, but in following slides and due to space constraints, we show the results from only the first trial. Yeah, these are the results of experiment 1. This figure shows the evolution of images at 10 generation intervals, and intervals for each word. Although there are 32 individuals per generation, we focused on analysis on the top 8 individuals to provide an appropriate evaluation of VLM selection tendencies. Yeah, this figure shows that when using words like warm and aggressive, a change in images colors and towards red and orange was observed. Yeah, next is cold and calm. A change in image colors towards blue and green hues was observed. Yeah, if the selection were completely random, the random result would look like this. This demonstrates that our system doesn't have a color bias. So this graph visualizes the transition between generation by setting the vertical axis as average RGB values, and the top 8 RGB values of the top 8 individuals in each generation. From this graph, in the random case, there's no clear difference between the red, blue, and green values. For words like aggressive or warm, the red value is significantly higher. And calm and cold, the blue value is notably higher. Next, experiment 2 examines sound symbolism. using the classic sound symbolic was Kiki Buba. Additionally, considering the possibility that Kiki Buba might be included in the VLM's training data, so we created a new third words, Chikike and Numor. Yeah, this one. The method for creating sound symbolic third words is as follows. Based on previous research, we classify the letters with sharp images, and letter with round images like this. After that, we created 4 to 6 letters words using these letters in all possible combinations, then eliminated existing words, and finally selected Chikike and Numor. Chikike is sharp image, Numor is rounded image. So here are the results of experiment 2. As with the previous experiment, we analyzed the top 8 individuals from each generation. So the results are displayed in this figure. From these images, for words like Kiki and Chikike, the images tend to change towards more linear and angular shapes. And in contrast, for Buba and Numoru, the images show a tendency to change towards more curved and rounded shapes. So this graph visualizes the result of experiment 2 using an algorithm to detect straight lines and curves in the images. So the vertical axis represents the number of curves in the image, while the horizontal axis shows the number of straight lines. So each plot point represents the average number of lines for the top 8 individuals across the 30 generations. Yeah, diagonal line serves as reference, and this graph shows for Kiki and Chikike. Upper side. Most plot points for below the reference line, indicating a higher prevalence of straight lines in these images. In contrast, for Buba and Numoru and lower side, the majority of plot points are above the reference line, so suggesting a higher number of curves in these images. Finally, in experiment 3, since it's unclear whether our newly created third words evoke sound symbolism in humans, we had human subject perform the same task instead of the VLM. Subject are 2 Japanese university students, 1 male and 1 female. Here are the results of experiment 3. And from these images, we can observe trends similar to those in experiment 2. Chikike is associated with images that evoke towards more linear and angular shape, and Numoru is associated with the images that develop more curved and rounded shapes. Yes, these graphs, similar to the one in experiment 2, quantifies these observations. Plot points for Chikike tend to fall below the reference line, indicating a higher number of straight lines. And plot points for Numoru are generally above the reference line, so indicating a higher, suggesting a greater presence of curves. Yes, these results imply that the third words Chikike and Numoru also evoke sound symbolic sensation in humans, similar to the classic Kiki Buba effect. This suggests that both humans and the VLM have similar tendencies to these sound symbolic words. Now let's discuss the implication of our experimental results. Yeah, regarding the color impression results from experiment 1, we observed that the VLM showed similar tendencies to humans for words known to evoke specific color impressions. It is so that human cognition and sensation are expressed in text, which the VLM then learned from. As an additional experiment, we are currently analyzing how each word is positioned in color space by extracting the color semantic components from the vectors of the words used in experiments. This is our discussion of the results from experiment 2 and 3. And experiment 2 and 3 suggest similar trends in sound symbolism between BLMs and humans. In humans, one theory suggests that sound symbolism is partly attributed to bodily sensation, such as the shape of mouth during pronunciation or the pitch of the sound. So it's interesting that BLMs, which lack physical bodies, demonstrate sound symbolic sensibilities even with pseudo words like jikike and numoru. Our current hypothesis is that BLMs may be making inference by focusing on the letters or syllables that compose these pseudo words. For example, if the jikike is vectorized into subword like this, this was subword, it became possible to make judgment based on the knowledge that these letters give sharp impressions. Therefore, similar to our car impression experiments, we are conducting additional experiments using word vectors for these aspects as well. Now summarize in discussion. This one is my conclusion. And for future work, we aim to conduct more extensive research and increase the number of words used in experiments and conducting experiments with other VLMs and increase the number of human subjects. And focus on sensory aspects beyond color impressions and sound symbolism. So these efforts will contribute to a broader understanding of BLM sensibilities. Thank you very much for your attention. This concludes my presentation.